In problem 12, we're asked at how many points in the xy plane do the graphs of y equals 4x to the fifth minus 3x squared minus 1 and y equals negative zero point 0.4 minus 0.11x intersect. And we'll definitely want to use our graphing calculators in this problem. So we just double check to make sure that we've input them correctly. 4x to the fifth minus 3x squared minus 1 and negative 0.4 minus 0.11x. If we zoom, standard, graph the two functions, we should see that apparently there is only one intersection of those. Now we can't be completely sure by looking at that graph that we have everything there. But first of all, what I'd like to do is to zoom in just a little bit. So I'm going to zoom and in, which is option number 2. Notice the flashing cursor at the origin. I hit enter and it brings it in a little bit so that I can see what's happening there. Now this doesn't guarantee me that there's only one, so you do have to be careful with this. The solution guide suggests that we might use calculus. What calculus would be able to do for us is, if you see in that x to the fifth function there are only two relative extrema, one at x equals 0 and one a little bit over to the right of that. Well, what calculus would be able to do is that in the fifth degree function, we would be able to determine how many relative extrema there should be. And if there were not two, but for example, if there were 4, if it went up and then came down and then went back up again, then we might have to check for a further possible intersection point. And we're going to look into that in a second. Now, because of the steepness of those slopes there on the 4x to the fifth function, and knowing that an x to the fifth function, as long as its leading coefficient is positive, has to start at negative infinity and end up at positive infinity, I'm fairly certain that there's only one here, but we can't be sure based solely on that. So let's talk briefly about how the calculus works here. We'll put the graphing calculator away. Well, if our fifth degree function, 4x to the fifth minus 3x squared minus 1, is y, then y prime would be 20x to the fourth minus 6x. We can factor out from that 2x, leaving 2x times 10x to the third minus 3, from which we can see that we have 1 0 at x equals 0, and we have other zeros potentially where 10x to the third is equal to 3. We divide both sides by 10, and we're looking for where x cubed is equal to 3/10. You might know that the x cubed function is a function that we call monotonic increasing, and so it is always increasing except where it has a 0 derivative at x equals 0. So there would only be one place where the function x to the third is equal to 3/10, and so we have from this we have 2 zeros, or we have 2 potential relative extrema in the original function, and that's exactly what we saw on the graph. So if you go back to the original graph, we had a point of inflection, we had a relative extrema at 0 and another one slightly over. That must be where the 3/10 is. And since there are no other relative extrema in that function, then we can be sure that the function doesn't dip down again and go back up to positive infinity. And so there will only be that one point of intersection.